This is a screencast for section 7.2, example 2. Again, we're going to look at the area of an enclosed region, and this time do a little bit more by hand and compare it with the calculator. So, example 2 says find the area of the region enclosed by the parabola y equals 2 minus x squared and the line y equals negative x. So, they gave us the picture here. But if they didn't, you would know that this parabola is upside down, and it was a shift up 2, and then y equals negative x passes through 0, 0. So you could tell that the line y equals negative x is below y equals 2 minus x squared. So you can see that your integration is going to be the antiderivative from a to b of the top function, the parabola, minus the linear function. Now the question is, what's a and what's b? Well, again, what if you have to do this by hand? So if you want to find an intersection by hand, set the two equations equal to each other and find their two x values that set them equal. I put the negative x squared and 2 on the other side, so I set it equal to 0, factored, and I get x equals negative 1 or 2. Those are the two x values that make the two equations equal to each other. So then a would be negative 1, b would be 2. So I can integrate from negative 1 to 2. And that's just simple power rule of integration, fundamental theorem part 2, and I get 4.5. Well, now let's look at that with the calculator, and I know these are simple. A and b is negative 1 and 2. It's not like a complicated decimal or anything, but at least we can get this process down. So I graphed in y1 the parabola and y2 the linear, found a good window. Now I did second calc intersect to find my a value, and I left the cursor on x equals negative 1, and then I stored that as a, so x stow a. Then I did the same thing for the second intersection, and I stored that as b, so in my calculator I can tell it to integrate from a to b. I know this is old school TI 83 stuff, but at least you can see what that used to look like. To now try problem number 5. It says find the area of the shaded region analytically, so by hand, and of course we're going to compare it to the calculator just to make sure we're right. Well, this one gives me a picture and endpoints or intersection points of the two curves, so it makes it a little bit easier. I'm going to integrate the top curve, 2x squared, minus the bottom curve, x to the fourth minus 2x squared, and that's going to be done from negative 2 to 2, the left x value to the right x value. Simplify a little bit, integrate, fundamental theorem part 2, more simplify, more simplify, more simplify, and finally I get 8 and 8/15. Now when I put that in my calculator, I'm going to integrate 2x squared minus x to the fourth minus 2x squared dx from negative 2 to 2, and I get 8.5333, whatever. So, and just to make sure, 8 and 8/15 is also 8.53333333. So we did it right.